Today we'll be talking about subatomic particles. We have protons, neutrons, and electrons. Protons are found in the nucleus. They are positively charged and they have a relative mass of 1. Neutrons are also found in the nucleus. Their charge is 0, they're neutral, and their relative mass is also 1. Electrons are found around the nucleus in the orbitals. Their charge is -1 and their relative mass is 0. Neutrons are a little bigger than protons and protons are a lot bigger than electrons. Atomic numbers are just number of protons in an element. For example, in nickel there are 28 protons and 28 is the atomic number. Isotopes are determined by the number of neutrons. And so nickel may have different isotopes, and the reason they're isotopes is because they have different number of neutrons. Charges are determined by the numbers of electrons. If you lose electrons, you gain a positive charge because electrons are negative. If you lose negative charges, you gain positive charges. Or you become positive. You become positive. Now, if you gain electrons, you're gaining negative charges, so you're becoming negative. Atomic mass are just the total number of protons and neutrons in an atom or an isotope. An isotope is just the isotopes with different number of neutrons. That's what makes up isotopes. Now, because they have different number of neutrons, they're also going to have different number of atomic mass because atomic mass is protons plus neutrons. When you're naming isotopes, you have to put the name first, the name of the element, and then you put the mass number. And so you would put, for carbon 12, you put carbon, which is the element, and then 12, which is the mass number or the atomic number. Hydrogen is the only exception for this rule because hydrogen has 3 isotopes and they're named very differently. Protium has 1 proton, and so the atomic mass unit, AMU, is 1. Deuterium has 1 proton, 1 neutron, and so the atomic mass unit is 2. Tritium has 1 protons and 2 neutrons, and so the atomic mass unit is 3. Atomic weight is the average of the atomic mass units of isotopes of an atom. And so for you to find the atomic weight of nickel, you would just average all the atomic mass numbers of all of its isotopes, and that will give you the atomic weight. And here's the atomic weight. It's just the average of all of nickel's isotopes. Now let's do this problem. What are the number of protons, neutrons, and electrons in nickel 58 compared to nickel 60 plus 2 cation? Nickel 58 and nickel 60 are isotopes because the 58 and the 60 are mass numbers. They're atomic mass numbers. And so they're isotopes of each other. Now for nickel 58, right, we're finding the protons, neutrons, and electrons. So for nickel 58, if you look in the periodic table, you would notice that the atomic number for nickel is 28. And so you already know there's 28 protons because that's what the atomic number is, just the number of protons. So there are 28 protons. Now because nickel 58 is neutral, the number of proton is equal to the number of electrons. So if there's 28 protons, there's also 28 electrons. Now let's find the number of neutrons. Number of neutrons is just, since you know that atomic mass is protons plus neutrons, you could just do atomic mass minus protons to give you neutrons. And so the atomic mass is 58, so you do 58 minus protons, 28, which will give you 30 number of neutrons. So there's 30 neutrons in nickel 58. Now for nickel 60 plus 2 cation, there are still 28 protons, because nickel has 28 protons. The charge is plus 2 because it says nickel 60 plus 2 cation. Since it's plus 2, you lost 2 electrons. The nickel 60 lost 2 electrons, so it gained positive charges. And so Since it lost 2 electrons, you got to do 28 minus 2, which will give you 26 electrons. Now the atomic weight is, or the atomic mass is 60. So you just do 60 minus 28, the number of protons, which will give you the number of neutrons, 32. Now, this is a problem that I would like for you guys to solve. You can just solve it without looking at the answers. It's just asking you to find the number of subatomic particles for these atoms. So these are the atoms, or the isotopes of these atoms, and just find the number of protons, neutrons, and electrons. The answers are already here, but if you could just ignore the answers and find the answers, and then let's just see if you got them right, that would be great. So afterwards, after you've solved it, protons, like I said, if you look on the periodic table for oxygen, the number of proton is 8 because that's the atomic number. It's right on top of the elements. So since the number of protons are 8, the number of electrons are also 8. All of these elements right here are neutral, so the number of protons will equal to the number of electrons. Now the number of protons is 8 for oxygen 16 and also 8 for electrons. Now for neutrons, you would do you would just do 16 minus 8 and it would give you 8. For oxygen 19, protons is 8, electrons also 8. For neutron, you would do 19 minus 8, which would give you 11. For fluorine 16, the atomic number is 9, so proton is 9, electron is 9. So 16, which is the atomic weight, minus 9, the number of protons, which would give you 7. For fluorine 19, the proton is still 8 because the atomic number is still, the proton is still 9 because the atomic number is still 9. Electrons 9, and you would do 19 minus 9, which would give you 10. And that would be the answer for this problem. If you have any questions, you can leave some comments below. But thank you, and see you next time.